Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
Hello. In this problem, we are asked to consider two different situations. One, where we have a particle moving at a 25-degree angle at some velocity v with respect to a magnetic field, v. Now, this angle we're given is 25 degrees. Now, we know that the magnetic force that this particular particle feels while traveling at this particular angle is equal to F. Now, we're asked to consider another situation, one in which the angle has changed, but everything else, mostly everything else, has stayed the same. So the object is going to be traveling at a different angle, but the magnetic field is still, say, this way, with the same magnitude. The particle is traveling at the same magnitude of velocity, but now we're traveling at an unknown angle. We do not know what this angle is. But we do know that the magnitude of the magnetic force that the particle feels in this scenario, which I'll remember to draw my little particle here, both of charge, let's say, Q naught, we know that this particle in this lower situation is going to be feeling a force of twice the amount as before. So the question is, what is this new angle that the particle is traveling at? Well, what we're going to do is analyze both of these situations individually and then link them through some variables that we're going to solve for. So for our top situation, let me kind of draw a line between the two. Let's write out what the magnitude of the magnetic force would be in terms of variables. So we know that the magnitude of the magnetic force is given by the magnitude of the charged particle, magnitude of the charged particle multiplied by its speed, then by the magnitude of the field through which the particle is traveling, and then multiplied by sine of the angle between the magnetic field and the velocity vectors. Now, this we know gives the magnitude of the magnetic field, and that is represented by our letter capital F here. So this is the statement for the magnitude of the magnetic force for our particle in the first scenario. Now, let's write out the magnitude of the force the particle is going to feel in the second scenario. We still have the same charge here. We have the same speed, same magnitude of magnetic field through which the particle is traveling, but now the angle is unknown. But we do know the magnitude of the force it feels. It is twice capital F, so twice the force it felt in the previous scenario. Now, what we're going to do is try to relate these two through variables that we know and do not know. For the top situation, I'm going to suggest let's solve for sine of 25, mostly because sine of 25 is just a number, right? If you plug that in your calculator, you can get a number, and that's going to relate to many unknown variables that we don't know, some mathematical collection of them. In this case, when we solve for sine of 25, we see that's equal to the force that this particle in scenario 1 feels divided by the magnitude of our charge times the speed of that charge multiplied by the magnitude of the magnetic field through which the charge is traveling. So we have this relationship, and we did this because we often do this in physics when we're comparing two situations that have several variables the same between the two, but with just several changes. And we can relate all of these collection of variables here to a particular number, sine of 25 degrees. Now, since we want to find what this unknown angle is here, well, let's solve for it in the bottom case. So in the bottom, we see that solving for sine theta, we get sine theta is equal to twice F divided by magnitude of Q naught times V times B. Well, if we rearrange this and pull our 2 out, we notice that we have a combination of variables, F divided by Q naught, V times B. But this collection of variables is the same as this collection of variables. and therefore is equal to sine of 25, which remember is just a number. So above we see that sine of theta is equal to twice sine of 25 degrees. So we solve for theta by taking the inverse sine of twice sine of 25 degrees. We plug that into our calculator and figure it out. We get that the answer is about 57 degrees, or sorry, roughly 58 degrees, accounting for significant figures. And that is our answer.